Good day, everyone. We are back again. We are still talking about quadratic equation. Okay, but this time around we are looking at cases where your b equals zero. Okay, if your b equals zero, you're going to be having quadratic equation of these forms we have here. So let's see how to resolve this kind of quadratic equations. Okay, so this is how you go about it. Right. So let's look at the solution one. We have x squared minus 4 to be equals to 0. Okay, so there are two ways of doing this. You can actually apply the difference of two square approach, or you apply what we call the alternative approach. So I'm going to be using the difference of two square. Okay, now the idea behind the difference of two square is this: if you have a square minus b squared, is always equals to bracket open a minus b bracket close, then bracket open a plus b bracket close. That means this is the same thing as x squared minus 2 squared. Okay, because 4 is the same thing as 2 squared equals to 0. Then this is just x minus 2 into x plus 2 equals to 0. So at this point, x minus 2 equals 0, or x plus 2 equals 0. Okay, that means x is equals to 2, or x is equals to minus 2. Okay, now let's look at the number 2. We have c squared equals 9. So the first thing we do is to move the 9 over to the left. So you have c squared, 9 moving now, you have minus 9 equals to 0. And this is the same thing as c squared minus 4 squared, because 9 is the same thing as 4 squared. And then from here, this is the same thing as c minus 4 into c plus 4, okay, to be equals to 0. So from here, either c minus 4 is equals to 0, or c plus 4 is equals to 0. That means c is equals to 4 or minus 4. Okay, then let's quickly look at the number 4 problem. We have 4q squared equals to 36. 4q squared equals to 36. Okay, so this is the same thing as um, 4q squared. You move 36 over to the left, that becomes minus 36 equals to 0. And then this is the same thing as 2 squared q squared minus 6 squared equals to 0. Okay, now according to the law of indices, 2 squared q squared can be written as 2q all in squared, okay, minus 6 raised to the power of 2 equals to 0. So from here, applying difference of 2 squared, you have 2q minus 6 into 2q plus 6, then to be equals to 0. Okay, and then from here, 2q minus 6 is equals to 0, or 2q plus 6 is equals to 0. So from here, 2q equals 6, or okay, 2q equals minus 6. And then from here, dividing through by 2, q will be equals to 4, the first, or q equals minus 4. All right, so let's quickly look at the number 4 here. We have 16k squared equals, I think, 49. Let's check. Okay, so it's still the same approach. So this is 16k squared, minus 49 equals to 0. And then this is just the same thing as 4 squared, expressing it as a squared, k squared minus 7 squared, okay, equals to 0. And then this is the same thing as 4k all in squared minus 7 squared is equals to 0. So from here, you have 4k minus 7 into 4k plus 7 equals to 0. Then this is just the same thing as 4k minus 7 is equal to 0, or 4k plus 7 is equal to 0. So which makes this to be 4k equals to 7, or okay, or 4k is equals to minus 7. So divided through by 4, which is the coefficient of k on both, this becomes k, to be equals to 7 over 4, okay, or minus 7 over 4. Okay, so which you can reduce now to mixed fraction if you want to. So let's quickly run through the fifth one, which is the one where we have 2b squared equals 2. Okay, so this is just the same thing as 2b squared, okay, to be equals to, minus 2 is equals to 0. So you can first of all divide through by 2, then that gives you b squared minus 1, okay, to be equals to 0. So this is the same thing as b squared, minus 1 is the same thing as 1 squared equals to 0. And then you just have it to be b minus 1 into b plus 1 equals to 0. So at this point, either b minus 1 is equal to 0 or, b plus 1 is equals to 0. So b is equals to 1 or, minus 1. Okay, so that's basically how to solve quadratic equation of this kind. Thank you for, always watching my video. Do well to comment, like, and then subscribe to my YouTube channel. And as you do that, God bless you. Thank you.